All right, so we're actually going to have the last lesson of this chapter today. It's about tolerances. So tolerances are basically just like a range of possible values that a measurement can take place within. We'll get in with this today. Here we go. So like I kind of alluded to, we're finishing off our second chapter today already. It was very quick chapter, to be honest, just 2 lessons long. We'll start with a quick review of adding and subtracting fractions, as we're going to need that skill today. At least we most likely will. There's ways to get around it, but we can talk about that as well. We're going to introduce tolerance and nominal values today. Those are the only 2 new terminology things we'll talk about, and then we'll do multiple examples. Let's get going. So first of all, some review of adding and subtracting fractions. Just a reminder, to add and subtract fractions, you need to have a common denominator. To get a common denominator, you basically just have to look at the denominators and say, hey, which one, or do I have to change both of them? Which one do I have to change to make it look like the other one? To change a fraction with a denominator, you just multiply the top and the bottom of the fraction by the same number. Anyway, easier to see with an example here. We have 2/9 plus 4/3. Well, they don't have the same denominator right now, but I can change 4/3 to being something over 9 just by multiplying the top and the bottom of this one by 3. So let's do this. 2/9 plus, if I multiply 4/3 on the top and the bottom by 3, that gives me 12/9. Now, the reason I chose multiplying by 3, of course, was because I knew 3 times 3 would be equal to 9. Anyway, now that they have the same denominator, you can just add the numerators, right? So 12 plus 2, or 2 plus 12, I should say, is 14. The denominator, however, when you add together fractions, the denominator does not change. So it's 14/9. And that right there, that's it. That's all there is to that, right? So not too bad, as long as you just understand how to change the denominator to be the same as the other one. Next one, 11/12 minus 3/5. Now, there's not a number that's obvious in my head right now what I could do to change both of these. So a way to kind of cheese this is just to multiply each fraction by the other one's denominator. So what I mean by that is, if I could multiply this 11/12, both the top and the bottom of it, by 5, that'll give me 55/60. So again, I just multiplied this by 5. And then I can multiply this other one by 12 on the top and the bottom. So that's going to give me minus 3 times 12 is 36 over 5 times 12, which is 60. So if you multiply each fraction by the other one's denominator, that's just a way of guaranteeing that the denominators will in fact match, right? Anyway, 55/60 minus 36/60. You don't touch the denominator, so it's just still going to stay 60 down there. 55 minus 36, I'm pretty sure that is 19. So we'd have 19/60, and there we are. Last one here, 2 5/8 minus 1/2. 2 5/8 is what we would call a mixed number, because it's a number with a fraction attached to it. As much as they're nice for communicating things, like saying, oh, you have like 3.5 of something. As much as they're nice for communicating things, they're really awful in terms of doing any math operations on them. So what I'll do is I'll change this mixed number into what we call an improper fraction first. To do that, you just take 2 and multiply it by 8. That gives me 16, and then you add it to the top 5. And the whole reason we do that is because we have 2 completed 8 out of 8s, right? So if we have 2 8 out of 8, so that means we have 16 out of 8 plus the 5 8 out of 8 that we already have there. Long story short, that gives me 21 out of 8 minus 1 out of 2. Now we want to change this so they have the same denominator. I think one that we can do really quick is just to multiply this 1/2 by 4 on the top and the bottom. So this gives me 21/8 minus, if I times this by 4 on the top and the bottom, I get 4/8. 21/8 minus 4/8 is 17/8. So that right there would be our answer. Now, the reason we care about this today is when we talk about tolerance, there's a lot of tolerances that are given as a fraction. Usually if something's given as a fraction, we want our final answer to be a fraction as well. Now, we can get around this by like changing it to a decimal, but generally speaking, we want to keep it as a fraction. So I'll show you what I mean as we get a little later on to that. First things first, though, let's actually talk about what tolerance really means. So just a little bit of background here. When products are built, there's often an acceptable range of allowed measurements for that object. It's not always practical to assume everything is built exactly the same each time. So whether it's clothing being manufactured or whether it's just merchandise being manufactured in a factory, oftentimes things aren't literally built exactly the same every single time. Sometimes certain items are a little bigger or a little smaller than others. Clothing especially, right? You could have 2 of the exact same pair of pants, and the waist might be a little bit off, even though the waist size on the labels is actually the same. They just weren't built perfectly the same each time. So the acceptable range that is given for products, they say, yeah, there can be a bit of an error, but we have an acceptable range. The acceptable range is called the tolerance. The target value, so what we actually want the true size to be, lies between the minimum allowed value and the maximum allowed value. So the tolerance is just the difference from the minimum to the maximum. So if they were 10 inches apart, the tolerance would be 10 inches from the minimum to the maximum. The target value, also known as the nominal value, is the number that lies right in the middle. It's what we really want the true size of the object to be. Now, tolerance can be expressed in many ways. You can just say the tolerance equals whatever. That's the obvious way of putting it. But there's 4 other ways that, oftentimes this is communicated. One of which is just to list the maximum value over the minimum value. The tolerance is just the difference between the two. But if you say, yeah, we have a maximum of this and a minimum of this, that kind of expresses the tolerance right there. Another way, this one is super common. The nominal value, which again is what you want your object to be built at. So if you were building pants with a waist size of 32 inches would be your nominal value. Plus or minus, that's what that sign means, plus or minus 1/2 times the tolerance. So half the tolerance going up and half the tolerance with the minus here going down. Remember, the tolerance is the distance from the minimum to the maximum. So half the tolerance goes above the nominal and half the tolerance goes below. Another way, these bottom 2 are pretty rare. I don't really see these too often, but they are still valid, is the minimum value and then plus the tolerance number listed up top and minus 0 listed below. How you read this is you go, okay, well, that's our minimum, but we could go up by our tolerance or down by nothing. Well, of course, you're going to go down by nothing because it's the minimum value, right? Likewise, another way you can see this written is the maximum value written with plus 0. So you're going to go up nothing, of course, because it's your maximum value, or minus your tolerance, right? I don't see those 2 very often. It's these top 2 I see most common, especially this one right here. But we do need to know all 4, unfortunately. So you'll want to maybe keep the note package in your notes somewhere so you can come back and refer to this every now and then, because a lot of this terminology is really weird. Coming back to your notes is always a really good idea. Anyway, let's get through this. So first example, a steak needs to be cooked to between 145 degrees Fahrenheit and 150 degrees Fahrenheit for it to be done medium, right? So if you're cooking a steak at medium, those are the temperature ranges that are allowed. What is the temperature tolerance as a number? Well, remember, the tolerance is defined as being the distance from your minimum to your maximum. Of course, we have this as our minimum and this is our maximum. So the distance between those 2 numbers, hopefully you can see it, is 5 degrees Fahrenheit, right? That would be our tolerance, right? It can be anywhere from this temperature to this temperature. The difference between that is, of course, 5 degrees Fahrenheit. Next question, express the range of acceptable values in the 4 ways mentioned earlier. So I'm going to scroll back a little bit real quick here. These 4 ways are what we need to do to express these different tolerances. I'm going to start with this first one, maximum value and minimum value. So writing it in that way, the maximum value, of course, is 150 degrees Fahrenheit, and the minimum is 145 degrees Fahrenheit. So that right there, it's just an ugly 0. Let me correct that 0 there. That right there, that's the first way we could represent this. The other way, if I'm going to go back, is that nominal value plus or minus the 1/2 times the tolerance. This is the most common way you see this. Now, it didn't tell us what the nominal value is here, but we do know the max and the minimum, and we also know the tolerance itself. Remember, your nominal value lies directly in between these 2 numbers. Now, there's a couple ways you could do that. You could either just use an intuitive understanding and go, okay, what number lies exactly between these 2? Or if you prefer, you can find the mean average between those 2 numbers. Hopefully you remember to find the mean average. You just add the numbers together and then divide by 2. If you do that, because I think honestly that's the most consistent way of finding it, if you find the average between these 2, that'll tell us our nominal value. If you add these together and divide by 2, I'll save you the trouble. It gives you 147.5. That's the number that lies directly in between those 2. So that's our nominal value. Now, we also have to write plus or minus 1/2 the tolerance. Well, remember, the tolerance from before, the tolerance was 5 degrees Fahrenheit. So plus or minus 1/2 the tolerance, half of 5 degrees Fahrenheit is 2.5 degrees Fahrenheit. So in other words, this is the second way we can represent our tolerance here, the nominal value plus or minus 2.5 degrees Fahrenheit. Of course, if we added 2.5 degrees Fahrenheit, we'd be up at 150. And if we minus 2.5 degrees Fahrenheit, we'd be down at 145. Okay. Next way, scroll back because these next ways are weird. The next way is to write your minimum value and then plus tolerance minus 0. So this way it'll go pretty quick. We know our minimum value is 145. So 145 degrees Fahrenheit plus your tolerance. So plus 5 degrees Fahrenheit and minus 0. That's another way of writing this. I really don't like this way. I think it's a stupid way of writing it, but it is what it is. The final way, almost the exact same. I'll go back. It's almost the exact same, except it's your maximum value plus 0 minus your tolerance. So to write that, maximum value is 150 plus 0 minus 5 degrees Fahrenheit, right? So this means you can go up by 0 or you can go down by 5. That's your whole range. Those bottom two, I think, are really silly. I don't like using them. I love this one. And then this one's also pretty clear as well. Basically, whatever floats your boat. If it doesn't say which one to use, just use whatever you're more comfortable with. If it just says, hey, what's the tolerance? You can just say it as a number. Because let's be honest, that's probably the easiest way of referring to that. All right, next one. Write the following in the form nominal value plus or minus 1/2 times the tolerance. In other words, that way that I say is always the most common. So it gives us a bunch of measurements. There's two different questions here. I'll just draw a line to divide this so you don't get confused. This first one, we have a maximum and we have a minimum. We need to find what our nominal value is. So remember, the nominal value is the value that's right in between the maximum and the minimum. Now, if you're pretty keen, you might be able to tell by looking at these two numbers what number lies right in between. But if you don't quite see it, that's okay. You can just find the average between these two numbers as well. To find the average, just add the two numbers together and then divide by 2. I'll even show it this time. 25.75 plus 25.25 and divide that by 2. I'll clean up the top first. If you add those two together, you'll find that you get 51, I think. No, you know what? I'm going to do this properly. Let me actually use my calculator. My mental math's not working for me today. Let's see. 25.75 plus 25.25. That equals, oh yeah, it was equal 51. See, there I was second guessing myself, but I did have it. Anyway, 51 divided by 2, that's going to give me 25.50. So 25.50, that's my nominal value. So writing this in the form nominal value plus or minus 1/2 times the tolerance, this gives me 25.50 plus or minus, 1/2 times the tolerance. Wait a minute. Well, the tolerance is just the difference from our maximum to our minimum. You could just subtract those two to find that tolerance. So the tolerance is just the difference between those two. If you subtract these two numbers, that I won't show, it's just 0.50. So plus or minus 1/2 times the tolerance, well, that'd be plus or minus 0.25, right? There's a lot going on in that one. I apologize. So just to kind of go over it one more time, to find the nominal value, just find the average between your maximum and your minimum. That's where you add them together and divide by 2. To find your tolerance, you just find the distance between the two. So you just have to subtract your maximum and your minimum. And then of course, 1/2 times that tolerance, that's what we're adding and subtracting. Here's another one. Maybe this one will work a little bit better. This one's going to be a little more tricky because there's negative numbers in here. Maximum of 35 degrees Celsius, minimum of negative 45 degrees Celsius. Maybe this is our temperature range in the region where we live. I don't know. But anyway, so to find our nominal value, we just have to find the average between these two. So 35 plus negative 45 divided by 2. That's actually going to give me negative 10 divided by 2. Negative 10 divided by 2 is negative 5. So negative 5 would be our nominal value. That's the middle value we have here. So negative 5, at least I think that is. Yeah, that works. Yeah, negative 5 plus or minus 1/2 times our tolerance. Well, our tolerance is the difference between these two. So the difference from the maximum to the minimum, you can find that by subtracting. So 35 minus negative 45. I believe if we do that, that's going to give us 80. You can always test that in your calculator, but no, I will confirm that is 80. So 80 is our tolerance. When we write this in nominal value plus or minus 1/2 times the tolerance, we have our nominal value plus or minus 1/2 times the tolerance. Well, 1/2 times 80 is 40. And I'll put units on this, say 40 degrees Celsius, just so we can stay consistent here. So what this means is the range that we see here goes from -5 up 40 degrees or -5 minus 40 degrees. That's all that's going on there. All right, here's another example. A tailor makes a pair of pants with a nominal waist size of 34 inches. The tolerance for waist sizes is 1/2 inch. Find the maximum and minimum waist sizes for this pair of pants. Okay, so tolerance, you just need to understand, is the range from your minimum to your maximum. We were given our nominal waist size. That's the middle number. The tolerance goes from the max to the minimum. So 1/2 of the tolerance is how much we go above or below the nominal waist size. Well, 1/2 of 1/2, so 1/2 of 1/2 is actually 1/4. So we're going to be going up 1/4 of an inch and down 1/4 of an inch. Now, if you prefer, in this question, there's nothing stopping us from writing this just as a decimal, 0.25. Maybe that would be easier, maybe it wouldn't be, it's up to you. I'll write it both ways. If we're going to write our maximum waist size, we're going to take our nominal and go up by 1/2 of our tolerance. So our maximum could be written as 34.25 inches, or if you prefer using fractions, you could write that as 34 1/4 inches. It works all the same. Our minimum is where we take our nominal and we go down by 1/2 our tolerance. So if we go 34 rather, and minus 0.25, that gives me 33.75 inches. Or if you prefer as a fraction, notice it would be 33 3/4. So 33 3/4 inches. Either way works, whatever floats your boat, go for it. Next one. The nominal value of a measurement is 16.056 meters with a tolerance of that many meters. Which of the following measurements meet the standard? So we have a whole bunch of measurements and we have to say yes or no, which ones meet the standard. Truth be told, I think the easiest way to do this is to find your max and min and figure out which ones of these lie within that range. Since we know our tolerance and we know our nominal value, we can find our maximum by just taking our nominal value and adding 1/2 of our tolerance. Remember, the tolerance is from the minimum to the maximum. So if you're going above your nominal, you have to cut this in 1/2. So we'll go 16.056 plus 1/2 the tolerance here. If I take this number and multiply by 1/2, that gives me 0.00035. Long story short, this gives me a maximum of 16.05635. Awesome. And then for a minimum, same idea, except this time we are subtracting away that 1/2 the tolerance, right? This one I'm going to want to use a calculator for. Let's see, 16.056 minus 0.00035. This gives me 16.05565. So this right here, this is our range. We have our minimum and we have our maximum. We need to look at all these numbers and figure out which ones lie within that. Let's take a look at this first one, 16.05672. Well, that looks, because of the 7.2 down here, that looks like it's actually bigger than our maximum. So no, that one would not be acceptable. What about this next one, 16.00 or 055757? Holy smokes. Well, that looks like it might actually be a little bigger than this number, but smaller than our maximum. So yes, that would be acceptable. As for this next one, 16.05605, I want you to think about this one yourself here. Compare it to these two numbers. Watch your decimals carefully. Notice they both have like 3 decimals to right there. Maybe I should erase that so it doesn't look like a 1. This one I would say is actually a yes. That one does lie within because it's smaller than what this number would be. As for this next one, I want you to really think about this one as well. Notice after the 0.55, we got an 8.5, well, that's bigger than a 6.5, so yes, that one works. This one is 0.56, so I should compare to this one. It's got 2.5 instead of 3.5, so I would say yes, that's within as well. As for this next one, it's a 0.55, I'll compare it to this, but then it's 6.55. Well, this is a 6.5 and then technically a 0. This one would be a little bit bigger than that, and that's a little bit bigger than our minimum. So yes, that one actually works as well. And then as for this last one, 16.05535, well, comparing it to this one, 3.5 is smaller than 6.5. So no, that is below our minimum there. That was a tough one. That was a really tough one. Anyway, are we done? Nope, we got like one last question. Here we go. All right, last one. Tolerance is a percentage. Sometimes tolerance is not given as an actual explicit number. Sometimes it's given as a percentage. So I'll show you how to work with this. A shelving unit is manufactured with an intended weight capacity of 80 kilograms. So that's how much that shelf is supposed to weigh. The manufacturer allows a tolerance of 5%. Determine the maximum and minimum weight capacity of these shelves. So when a tolerance is listed as a percentage, you have to compare it to what the weight capacity actually is as a real number. So as 80 kilograms. 5% of 80 kilograms can be found just by multiplying 80 kilograms by 5%. Remember, 5% is actually 0.05 because it's 5 out of 100. That's what percent means, right? So 80 times 0.05, that's actually 4. So our tolerance as kilograms, our tolerance is actually 4 kilograms. Now, remember, your tolerance is your difference from your minimum value to your maximum. We know 80 kilograms is what the intended weight capacity is. In other words, 80 kilograms is what we would refer to as being our nominal value, right? Tolerance goes from minimum to maximum. Nominal sits right in the middle. So we should take our tolerance and cut it in half and add it and subtract it from our nominal value. So our maximum here would be 80 plus half of 4. So that would be 82 kilograms. And our minimum acceptable value would be our nominal minus half our tolerance. So that would be 78 kilograms. Notice the difference from our maximum to our minimum is that tolerance of 4 kilograms. So long story short, when a tolerance is given as a percentage, it just adds an extra level of detail to it. And it makes you have to do one extra calculation to find what the tolerance number actually is. In this case, because we knew what our nominal value was, the tolerance of 5% is just 5% of that 80 kilograms. That's all there is to it. Anyway, this is the kind of stuff that needs a lot of practice. The terminology is kind of weird. It becomes way easier if you do a bunch of questions with it. So unfortunately, we got some practice ahead of us here. The worksheet that I've attached in our booklet is what we need to work on. As always, make sure you are reaching out if you have any questions or are stuck on any questions at all. Anyway, best of luck.